to finish off with CYPHER, I want to show you a third query, which is how we find which matches were played in a season. In the fan zone, there's a section called historical fixtures, which shows all the matches, season by season, going back to 1905. And if we take our pool of entities, we're going to use these entities. This is what the historian would say. And he'd phrase it like this. Find every league match played by Chelsea in the 2016-2017 season. That's how he'd phrase it. Now, finding every league match, we know how to do that query. We don't know the detail, but we know the rough syntax that we've shown before. We're just using competition in order to find that. And this is, I just realised, but as an aside, so this is a page we wrote along further on in the project, and we didn't know how we'd be searching between matches and competitions at the time. So in order to make the graph easy to understand, we put generic placeholders in to say, you know, we've got a relationship to this record, use the name of the record, also the destination record, use it also as the name of the relationship. So that's why we've got competition here to a competition record. And that's something at some point, if we ever need more nuanced relationships, we'd go back and rename or add additional relationships to. But this is a...
That's not an error then, as it stands.
That's not an error. That's valid. We've never needed... We don't have multiple relationships between matches and competition, so we've never gone back and revised this part of the data model. Never needed to. So this is a good... If you're struggling to name your relationships, just start with that. What record's at the end? Use that as your relationship name to start off with, just to get you going. We're looking for matches played by Chelsea. And again, that's syntax, more or less, that you've seen already. Here's the bits I've added. There's one new thing here, which is I'm matching on two relationships, not one. That's the or sign there between home team and away team. Every team is assigned either the designation home team or away team in a match. So rather than create three relationships to say, oh, they also played in the match, we're just reusing those relationships that we know must be there, because we need to know for display purposes which team was home and which team was away. So we put them in the right place on the screen. So there's nothing really new there. This, go on, I see you bursting to say something. How do you do with cup finals? One team still designated the home team, even in a cup final.
Chelsea haven't got to the cup final.
Oh, I'm glad he's not here. I'm glad our historian's not here.
I've heard of football, but I've never been it.
But no, every single match, one team is always designated home, even if it's a neutral venue. There's still always a home team and an away team in the official designations. I was surprised as well. You think, but that's the real world. That's what happens in the real world. It's not as neat and tidy as we'd like. Although in this case, we're taking advantage of the fact it seems quite tidy, even when it seems a bit nonsense. But how do we find the season? This is the interesting bit, and the reason I've picked this query out. And the reason it's interesting is because football seasons are like tax years. They don't line up to the calendar. They start in one year, but they finish in the next year. Now, there's an underlying principle I like to employ when I'm designing data sets, especially ones that are going to have lots of queries run against them that we don't know about today, and that's make them discoverable. So how would you tackle this? If you want to find these seasons, how would you do it? How would you do it in a relational database?
Yeah, the foreign key and competition to season or something.
Foreign key, competition to season, yep, that's one way to do that. At that point, then your competition, then you've got to have a record per season.
Yeah.
That's the trade-off there.
Or perhaps the match.
We could go from match to season, yep.
Table of valid years.
Table of valid years. Okay.
So for Northern Hemisphere matches,
Yeah.
it will always follow the pattern of 1 year then the next year.
Right.
But for matches in the Southern Hemisphere, that's not true.
Yeah.
Seasons take place in one calendar year.
Yes.
So in a relational database, it's a foreign key onto a table of valid years.
Yeah. And of course, if you start to go away from football and introduce other sports into this data set, it complicates things again. Yeah. So, sort of what you're saying. How many of you have heard of data dimensions and dimensional modeling? No. Wow. Really? Okay.
I remember that name. Maybe to have some vaguely
Okay.
things like it.
It's a technique from data warehousing, and they are a classic way of making records discoverable.
Let's say I thought I recognised it from my SAP BW days. A long time.
It's quite possible. I've not done any SAP, so.
Yeah, the dimensions, they talk about that a lot. I wasn't working very, very long.
The source of information about this, it was pioneered by a group of people known as the Kimball Group, who grew old and retired. They closed down their practice in 2015 because they're old and they retired. How wonderful is that? Seriously, most people don't get to work in this industry their entire life and retire. They normally leave the industry and go into another industry. Huh? They got to do it all the way through their lives and retire. And they retired because they were old, not because they cashed out. That is seriously awesome. But the website's still up, and all the books are still available that they wrote on this stuff. And I have many, many copies of them around the house. I think I've got 4 copies lying around the house last time I checked. It's really useful stuff. So if you want to know more about data dimensions, go get it from the horse's mouth. But the core idea of a data dimension is it's a standardized data set that you can use to link many different types of record to at the same time, which is sort of where you're going with your year thing. I've been talking about UK addresses, and they're a classic data dimension. Because you can buy the list of UK addresses, preload them into your database, and then when someone wants to send a parcel somewhere, you can link to it and say, okay, well that's their home address. And you can link to it and say, oh, that's also their billing address, or they may have a different billing address, and those sort of things. Which in a graph database is just the relationships between the records in order to create that identity and say what that address is at that moment in time. It's awesome. Now, there's no hard and fast rules about what is and isn't a data set. Is a data dimension. You don't go and buy my first 100 data dimensions to load into your database. You can make up anything that you can standardize. But the idea is you do standardize them and preload them in advance so they're always there to link to. And once they're there, they're kind of immutable. You might correct a mistake in them, for example, but if an address changes because it's issued a new postcode, you'd load that as a separate address, for example. You'd have a record to link the two, but you would put it as a different one because you want to know that that's what it used to be. So they're kind of immutable. And I'm probably glossing over a lot of the other things that are important about data dimensions. And time, and the different ways you can carve up time, is always a classic for data dimensions. I haven't worked on many databases with data dimensions, but they've always had time-based dimensions in there. So for example, hours in the day is a dimension. Even if it's got 24 entries, you can put that in there. Minutes in the day, minutes in the hour, that sort of thing. They sound so small, they sound like they should be data points in other records, but by putting them into a dimension and linking to them, you can then use those to discover records, which of course is path traversal, which is what graphs are great for. So we're going to have a year entity, and we're going to have 2 relationships from the season to the year to say which year it started in and which year it ended in. So we're introducing the year entity now to our pool. And once we've got that and we've built those relationships, it makes the query very simple to find the season. By getting your data right first, you eliminate all this calculation and all the ambiguity. And it doesn't matter what sport that's for. It's always going to find the right year for that sport, whatever that season is, once you filter on it. Because you've sorted your data out, so you've reduced the amount of calculations you've got to do. So we now know how to do all of this. We now know how to find all these elements. Now, for now, the queries have been following the same order that we've been saying them out loud. But this is an example where you might want to change that up a bit. See, we know there's only ever going to be one season that matches. So it makes sense to find that first and then feed that into the aggregate query. And by doing so, we can filter on it down at the very bottom. And this is also something new you've not seen yet, which you can actually use the relationship syntax from the match statement. You can use it in where clauses as well, which is really, really neat. That one does take a while to get your head used to it because it's just so alien to write something like that. But once you get used to the fact you can actually use it in a where clause as well as a match clause to help you filter out, it makes aggregate queries so much easier to write. It's really handy. And yeah, that's how you find seasons. That's how we find seasons in the data set that we've got live at the minute, using those techniques. Yep, so CYPHER, relationships in between records in where clauses. If you start using it, take advantage of that. Simplifies things a lot. So we've covered quite a lot with graph databases, going from absolute zero. I've shown you how to find things by their relationships. I've shown you how you filter what you find in the match statement. I've shown you how to filter them in the where clause using both the content and the relationships as well. I've introduced you to several aggregate queries and shown you how to do those and how to structure those. I've discussed using relationships to give identity to records. And I've introduced you to data dimensions in order to help you make records more discoverable. That's CYPHER. What do you think? It does, doesn't it?
Yeah.
So my client has staff who've taught themselves CYPHER because I don't operate the live system. I deliver to them and they operate it. So they've taught themselves bits of CYPHER so they can start having a poke around as well. And they've just picked it up and started using it, just from the documentation. I've not written queries for them for them this kind of things. They've just started exploring it on their own. It's just awesome with that respect.
How does that work with, like, actually, say, populating the data sets and putting that sort of data into it? Are they handling all that as well then themselves?
No, I actually do that. What we have is we have a data-based API in front of Neo4j. We're not exposing Neo4j directly to WordPress or anything like that. And I've written an ETL system that will actually load the data in for them. So they give me a raw data set, I do transforms on it, load it into Neo4j,